Today is a fun lesson, in my opinion. I really like it. I think it makes sense. It's constant rate of change.
Oh, no.
Why?
It sounds complicated.
Not. Promise.
Did we learn it last year?
You already know what it is.
I probably forgot it over the summer.
You didn't do it in sixth. You didn't do it in 6th grade, but I promise it's not difficult. So it's just a lot of vocabulary, and the vocabulary all kind of means the same thing. So first word is rate of change. The rate of change. Now, the title of the notes is Constant Rate of Change. If you read it backwards, it kind of explains itself. This is the change. This is how much something is changing, and it's constantly changing. So like on our builders that we've been doing, these, right here, that's the wrong one. Like right here, 2 times x. So this is going to be going up 2 every time. This goes up 1 every time. This goes up 2 every time. That's a constant rate of change because it's not changing. It's going to stay the same. It's going to stay constant forever. Okay? So the rate of change is how much something changes. You're comparing y to x. How much something changes and you compare y to x. It's important that you get used to that whole y to x idea. It is not x to y. It has to be y to x. Now, this is something you did learn last year, proportional relationship. Proportional relationship. A proportional relationship, it's a ratio of y to x that doesn't change. So if you were to take y divided by x, it never changes. Something is proportional if you can always take that coordinate xy. So you have that coordinate xy. That's what I'm talking about when I say x's and y's. And if you do y divided by x, you get the same number every time. That's proportionate. And you should have learned last year that a proportion is 2 equal ratios. 2 equal ratios. You probably saw something like 1/2 equals x over 10. This is a proportion. They are equal. You're generally finding the missing piece. It's proportionate because it doesn't change. Your y over x would be equal to the next y over x. And then the big thing for 7th grade, this next piece, it sounds scary, but it's not. It's just a division problem. The constant of proportionality is a formula. K equals y divided by x.
Yeah, I see what you mean about these all kind of mean the same.
It's all the same. It's just different words for the same thing. Rose by any other name, still rose. Like it. Rate of change is how much something changes. Proportional relationship is something that's never changing. Constant of proportionality is just rate of change. Y to x, y to x, y to x. Because they're going to call it different things and you need to know, oh, that's just the same thing. And even all of this is kind of like unit rate. So like this right here is kind of like yesterday when we figured out unit rate. If you got $10 for 2 gumballs, that's expensive gumballs, $10 for 2 ice cream cones. How much is each ice cream cone? So your y divided by x would be 5. Your unit rate is 5. Your constant of proportionality is 5. It's all the same. Okay?
Are you buying the gumballs made of gold?
Yeah, it sounds that way. Alright, science people, where you at? People that like science. There's usually a lot of y'all in math classes. When you have your graphing, we're going to start getting into graphing here. This triangle is delta. That is delta y over delta x. And we read that change in y over change in x. These deltas are just math symbols that mean change. Now, in science, oh yeah, delta. So don't forget. Delta. In science, you have independent and dependent variables. Time is independent. We cannot control time. It is always happening. We can measure time. So when you graph an experiment in science, which axis does time usually go on? X or Y? X, yeah. So time is independent. And Y is dependent. Because you decide what X is, and Y is what's happening because of the X you picked. So like if I go to the store and I want to buy 5 boxes of cereal, I would have to pay money based on the fact that I bought 5 boxes. I wouldn't go to the store and say, here's 20 bucks, give me as much cereal as that will buy me. That's not how that works. So independent would be the boxes of cereal. How much money I owe is dependent on how many boxes of cereal I bought.
I really wish I could just go to the store and say, like, here's $10. Give me all the cereal I can buy.
I would love to go to the store and say, I have $100, give me food for the week. That would be cool.
Like 5. Here's your lactose plate.
Alright, you're going to have to be able to interpret tables. So if this is my table, you have a vertical table, break it into 5 pieces. 2, 3, 4. I do a bad job of this every period. You have pounds and money. Let's say hamburger meat. I'm going to go buy pounds of hamburger meat. Pounds and money. In science, just like math, just like independent, dependent, I don't go to the store and hand them money and they give me pounds of hamburger meat. I go pick up pounds of hamburger meat and they tell me how much money I pay. So this is my X. This is my Y. They will always be in that order in a table. X is on top. What?
I like this other world you're suggesting.
Oh, where you can like give the money and they, yeah, where things are backwards. So we've got X over Y. It will always be like this in a table. If you have a vertical table, X is on the left. When you have tables and you have to know, okay, which one's the Y, this is the order that they're in. X, Y, X, Y. Now if I buy 1 pound, 2 pounds, 3 pounds, 4 pounds, let's say 1 pound of hamburger meat is $4. Yeah. So 2 pounds of hamburger meat would be $8. 3 pounds of hamburger meat would be $12. 4 pounds of hamburger meat would be $16. You knew how to fill this table in because you knew that the rate of change was constant. There wasn't going to be a trick question where you hit 4 pounds and all of a sudden it was $10. It's a constant rate. The graph is constantly going up. Okay? Constant rate of change. Constantly changing. Okay? Now, my example is always Bath and Body Works because you can go and buy soap, and one soap is like $7.50, but if I bought 4 soaps, they were $20. So like soap 1, $7.50. Soap 2, $7.50. Soap 3, $7.50. But once I hit the 4th soap, my graph would drop to $5 a piece. So $7.50, $7.50, $7.50. I'm at $23, and then it would drop to $20. Okay? Alright. So, step 1, to figure all this out, you have to find out how much is it changing. How much, thank you, is each thing changing? And by changing, I mean division. Or I'm sorry, subtraction. So my pounds was going up how much each time? 1. So 1 plus 1 plus 1. Okay? And then my y is changing how much each time? 4. Plus 4 plus 4 plus 4. That's all you have to do. If you can get that part, you're halfway there. Step 2, because it's going up, up 4, up 4, up 4.
Oh, I was like going off of like 1 times 4 or 2 times. That's what I was going off.
You're jumping ahead, but good that you're seeing it that way. 1 times 4, 2 times 4, 3 times 4, 4 times 4. What you just pointed out is our constant of proportionality, which is what we're going to do for 2. My change in y goes over the change in x because my formula is k equals y over x. So pick a y. Any other y's? Which y?
8.
8, okay. What is the x that goes with the 8?
2.
So 8 over 2 is... No, you're right the first time. 4. So my constant of proportionality is 4.
Is that a K?
Yes. So what this means is that each pound is $4. What did we call this yesterday? When we figured out how much one thing was?
Unit rate.
Unit rate. It's all the same. This is unit rate. Everything is going to be 4, up 4, up 4, up 4. Also, you can take it like this. The change in y over the change in x is 4 over 1, which is equal to 4. It's all the same. Just spirals around and around and around.